Welcome back to the deep dive. I was trying to explain the cloud to my dad the other day, and I realized I was falling into this massive, lazy trap.
Oh, yeah.
I basically told him it's just a giant invisible hard drive floating over a data center somewhere. You drag a file, it goes up, and you're done.
Which is the classic abstraction. It's comforting, right? We want to think of it like electricity. You just plug something in and the lights turn on.
Exactly.
You don't care if it's hydro or nuclear. You just want the voltage.
But then we started digging into this material on AWS storage services, and honestly,
Yeah.
that giant hard drive analogy isn't just wrong. It's actually dangerous.
Mm.
If you treat the cloud like some generic USB stick, you're going to lose money.
Yeah.
And you might actually lose data.
It's not just a technical error. It's a strategic failure. The reality of AWS or, any major cloud provider is that storage is this complex ecosystem of highly specialized tools. We aren't just talking about where you park a Word doc. We're talking about everything from lightning-fast drives for, say, high-frequency trading all the way to literal semi-trucks full of servers driving down the highway.
And that is what we are unpacking today. We're going to navigate the alphabet soup S3, EBS, EFS, Glacier. Because this is the part that really surprised me. There are storage types where if you just turn the computer off, the data vanishes.
Oh, gone forever?
That is terrifying.
It is if you don't expect it. But if you know why it works that way, it's actually a superpower.
Okay.
And that's our mission today. Figuring out not just where to put the data, but why it matters for your wallet and for your sanity.
So let's start at the foundation, the Great Divide. The material makes this huge distinction between block storage and object storage.
Mm-hmm.
And I've sat in so many meetings just nodding along to these terms, but if you press me, I couldn't tell you the actual, mechanical difference.
You are not alone. It's probably the most common confusion in cloud architecture. So let's start with block storage. This is the traditional approach. It's what your laptop's hard drive does.
Okay, so how does it work under the hood?
Imagine a parking garage with numbered spaces. The system breaks your data down into these fixed-sized chunks blocks, and it parks them in specific spots.
Right.
It says, okay, this piece of the file is in spot 4, level 2. This other piece is in spot 5.
It's very rigid.
It is rigid, but because it's so structured, it's incredibly fast to modify. If you need to change just one sentence in a massive document, the system knows exactly which parking spot to go to. It changes that one block and just leaves the rest alone.
That's precise.
Exactly. That's why block storage is the standard for things like databases or running an operating system.
Okay.
If you're running a high-performance database with thousands of transactions a second, you need that parking garage precision. You need that low latency.
Okay, so that's block. Structured, fast, good for things that change a lot. Now, how does object storage compete with that?
Object storage is a totally different paradigm. So forget the parking garage. Think of a massive valet service at a warehouse.
Okay.
You hand over your data, photo, video, whatever, and the system treats it as a single distinct object.
So it doesn't break it into pieces.
No. It bundles the data with something crucial, metadata. This is like a customizable tag that tells you what the data is, who owns it, when it should be deleted, stuff like that.
Right.
And instead of a parking spot number, you get a unique ID, a retrieval key.
So I give the valet my keys, I get a ticket, and I don't care where they park the car.
Precisely. And because you don't have to manage that complex parking garage structure, object storage can scale, infinitely. In a block system, if you have 1 billion files, that directory tree gets so heavy it slows everything down. In object storage, it's just a flat address space, 1 billion files. Fine. The system just looks up the ID.
So block is for speed and structure, like a database.
Yeah.
And object is for scale and unstructured stuff, like a huge pile of photos or backups.
That's the rule of thumb. And that brings us to the big player in the object world, S3.
The simple storage service? I feel like S3 is the one service everyone has heard of, even if they don't really know AWS.
Oh, yeah. It's the backbone of the internet, really.
But looking at the use cases, it's doing a lot more than just holding files. It mentions hosting static websites.
Right. This is a classic aha moment for people. Because S3 objects are accessible via a URL, you can actually host a full website, HTML, CSS, images directly from a storage bucket.
Without a server.
You don't even need a server. No operating system to patch, no software to crash. It's just files sitting there being served to the world.
That seems incredibly efficient for, a blog or a landing page. But what about the heavy lifting? The material connects S3 to things like Athena and Redshift Spectrum.
This is the whole data lake concept. You just dump all your raw data user logs, sales figures, whatever, into S3. Then, instead of moving that data into a database to analyze it, you use tools like Athena to run SQL queries directly on the file sitting in S3.
So you're querying the storage itself.
Exactly. It decouples the storage from the compute. It's massive for big data analytics.
Now we have to talk about the money, because S3 isn't just one price tag. It has this menu of storage classes. And this is where I feel like people get in trouble.
They do. The default is S3 standard. It's hot storage, fast access, redundant across multiple zones. It's the premium option.
But if I'm storing backups that I'm probably never going to touch, I shouldn't be paying premium prices for that.
Correct. And that's where you look at S3 standard infrequent access, or IA. It's significantly cheaper for storage, but, and here's the catch, they charge you a retrieval fee.
So it's cheap to park, but expensive to leave.
Right. It's designed for data you might need quickly, but rarely. Think like a disaster recovery backup. You hope you never need it, but if you do, you need it now.
Then there's this feature that sounds a bit like magic. S3 Intelligent Tiering. It says AWS just monitors your data and moves it between tiers automatically.
It's the autopilot. It looks at your access patterns. If you haven't touched a file in 30 days, poof, it moves it to the infrequent access tier to save you money.
And if you access it again,
it moves it right back.
Okay, play devil's advocate here. If it saves money automatically, why wouldn't I just turn that on for everything? I mean, why does the standard tier even exist then?
Great question. There is a small monitoring fee for intelligent tiering. It's tiny. It's per 1,000 objects. But if you have millions of tiny files that you know you're going to access all the time, that little monitoring fee might actually cost you more than the savings.
So it's not a magic save money button.
Yeah.
You still have to do the math.
Always do the math.
Speaking of saving money, let's go to the bargain basement. The deep freeze. Glacier.
Glacier is purely for archiving. This is data you are keeping because of compliance laws or historical records you just can't throw away.
The digital equivalent of a box of old tax returns in the attic.
Exactly. And just like the attic, it's hard to get to. The cheapest tier, Glacier Deep Archive, is incredibly inexpensive. We're talking pennies per terabyte.
Wow.
But the trade-off is retrieval time. If you ask for a file, you might wait 12 hours to get it.
12 hours.
Yeah.
In the age of fiber optics.
It's deliberate. It lets AWS store that data on slower, cheaper media or even spin disks completely down when they aren't being used.
But then I see Glacier Instant Retrieval. That sounds like a complete paradox.
Right.
How could it be Glacier, which I think of as cold and slow, but also instant?
It's for a very specific niche. Imagine medical imaging. You have x-rays from 5 years ago. You almost never look at them. So you want the cheap storage of Glacier.
Right.
But if a patient walks into the ER, the doctor can't wait 12 hours. They need that x-ray now.
So you pay a low storage rate, but I'm guessing you get hammered on the retrieval cost.
Exactly. You pay a premium to pull the file out. It's optimized for rarely accessed, but instantly needed.
Okay, so we've gone from the attic to the ER. But all of this assumes we can actually get the data into the cloud in the first place.
Right.
And this next section is my favorite because it feels so, I don't know, low tech.
The Snow family.
It sounds like a sci-fi villain squad.
Mm.
But we're talking about physical boxes.
We are, because here's the problem. Bandwidth is finite. If you have a petabyte of data, that's 1,000 terabytes, and you try to upload that over a standard business internet line, do you have any idea how long that takes?
A week, a month.
Try decades.
Yeah.
Literally, the math can work out to 20 or 30 years.
Okay, so the cloud is just too far away.
Right. So the solution is to stop trying to use the internet. AWS sends you a device, a Snowball. It's this rugged gray box. You plug it into your local network, copy the data onto it, and then a shipping label just pops up on its e-ink display.
And just call UPS.
You hand it to the carrier, they drive it to an AWS data center, and Amazon plugs it in directly. It's SneakerNet on an industrial scale.
And for the truly massive data sets, there's the snowmobile, which is,
And so,
it's a truck.
it's a 45-foot-long shipping container on a semi-truck. It pulls up to your data center, runs these huge fiber cables into your building, and just sucks up exabytes of data.
It's hilarious to think that the fastest way to move data in the 21st century is a diesel truck on the highway.
Never underestimate the bandwidth of a station wagon full of hard drives hurtling down the freeway.
There's a specific use case here that just feels like it's out of a movie plot. Forensics.
Oh, this is fascinating.
It mentions collecting data in compromised environments.
Well, think about it. If you're law enforcement raiding a cyber criminal's server farm or you're on a battlefield collecting intelligence, you can't upload that data.
Right.
A, you might not have internet, and B, it's not secure. You need a chain of custody.
So you dump the data onto a snowball, which is encrypted and tamper-proof, and you physically carry it away.
Exactly. It creates an air-gapped physical record. It's the ultimate security protocol.
Okay, so Snowball is about data that is so permanent and heavy it needs a truck. I want to flip to the exact opposite. The trap I mentioned in the intro, storage so temporary that if you blink, it's gone.
We're heading back to block storage now. Specifically, the storage attached to your virtual servers, your EC2 instances.
Usually when you launch a virtual server, you use EBS Elastic Block Store.
Right, and EBS is like a network drive. It lives independently of the server. If you shut down the server, the EBS volume is fine, your data is safe, it persists.
That's how I expect computers to work.
Right.
But then there's Instant Store or ephemeral storage.
Ephemeral is different. These drives are physically attached to the host hardware that's running your virtual machine.
And the warning here is stark. If the server stops, data is lost.
Not just if you delete it. If you just stop the instance, like shut down, the data on that ephemeral drive is wiped, reset.
Why on earth would anyone use that? It sounds like a trapdoor.
It's all about physics. Because the drive is physically inside the server, there is no network hop, no cable to travel through. It is incredibly fast. We are talking millions of IOPS.
Okay, quick definition. IOPS.
Input-output operations per second. It's basically the speed limit of how many times you can read or write to the disk. EBS is fast, but Instant Store is screaming fast.
So it's for temporary stuff, like caches or buffers.
Exactly. If you're processing a massive stream of data and you just need a scratch pad to do the math before you send the answer to a database, you use Instant Store? Who cares if the scratch pad gets wiped? You already have the answer.
But if you accidentally save your database there,
Then you have what we call a resume generating event.
I like that euphemism. Okay, let's pivot to something a bit more collaborative. We've talked about block storage being a parking spot for one car. But what if we need a parking lot that everyone can access at once?
That's file storage. And in AWS, the main service for that is EFS Elastic File System.
How does this differ from the block storage we just talked about?
Well, block storage, like EBS, can usually only be attached to one server at a time. It's a private drive.
Okay.
EFS is a shared drive. You can have hundreds of servers all mounted to the same EFS file system.
Mounted, meaning they all see it as just a local folder.
Exactly. They can all read and write files to it simultaneously. It's crucial for things like content management systems where multiple web servers all need to serve the same images.
And it just scales automatically.
You don't provision size, you just dump files in and it grows. You delete files and it shrinks. You just pay for what you use.
But EFS is Linux native. So what if I'm a Windows shop? Or I need something super specialized?
Then you look at FSX. I like to call FSX the specialist here. It's not one thing. It's a family of file systems managed by AWS.
I see FSX for Windows, which makes sense. But then there's FSX for Lustre. That sounds fancy.
Lustre is a high-performance file system used in supercomputing. Think about weather modeling or oil and gas exploration.
Heavy math.
Huge math.
Yeah.
These simulations need to feed massive amounts of data to thousands of CPU cores instantly. Standard storage would just choke. FSX for Lustre is built for that kind of massive throughput.
So AWS is basically saying, we'll manage the hardware. You just pick the flavor of file system your app needs.
Precisely. And they even have a feature called Amazon File Cache that kind of ties this all together. It allows you to create a high-speed cache in the cloud that sits in front of your data, even if your data is on premises.
So it's like a speed boost for data that isn't even in AWS.
It creates the illusion that the data is local. It keeps all the frequently used files ready to go with sub-millisecond latency, while the actual master copy sits safely back in your data center.
Which feels like a perfect segue to the final piece of the puzzle. We've stored the data, we've moved it, we've shared it. Now, how do we protect it?
This is the non-negotiable part: backup and disaster recovery.
There's a tool here called Data Lifecycle Management. This seems to be all about automation.
It's about removing human error. You can set policies to automatically take snapshots of your EBS volumes, say every 6 hours. But just as importantly, it deletes the old ones.
Right, because paying for a backup from 2019 is probably a waste of money.
Exactly. But the real heavy hitter here is AWS Backup. It's a centralized service that manages backups across almost everything: EBS, databases, EFS, you name it.
There's one specific feature in AWS Backup that I want to highlight because it feels incredibly relevant to all the news lately. Vault Lock.
This is your ransomware insurance.
It uses the worm model, write once, read many. Can you explain why that matters in a cyber attack?
Okay, so imagine a hacker gets into your system, they encrypt your live database, then they go looking for your backups to delete them, so you have to pay the ransom.
That's the standard playbook.
Right. But if you have Vault Lock enabled, they hit a brick wall. That backup is immutable. It cannot be deleted or altered. Not by the hacker, not by the system admin, not even by the root user account.
So even if they have the keys to the kingdom, they can't burn down the vault.
They physically cannot do it until the retention timer runs out. So you just wipe your infected environment, restore from the locked backup, and you don't pay a dime in ransom.
That is powerful. And finally, for when things really go sideways, fires, floods, meteor strikes, there's elastic disaster recovery.
DRS. This replicates your data continuously to a staging area in AWS. If your primary data center goes dark, you hit a button, and AWS spins up your servers in the cloud within minutes.
And it mentions you can grill this.
That's the game changer. In the old days, testing disaster recovery meant scheduling a weekend where everyone holds their breath, you pull the plug, and you pray it works. It was expensive and risky.
So nobody did it.
Exactly. With DRS, you can launch a drill in an isolated sandbox. You prove it works, you fix any issues, and you never disrupt your actual business.
We've covered a massive amount of ground here. We've gone from the parking garage of block storage to the infinite warehouse of S3. We've talked about trucks full of hard drives and cache drives that wipe themselves clean.
So it's a lot.
If you had to boil this all down to one takeaway for someone listening who is maybe feeling a bit overwhelmed by the alphabet soup, what is it?
Stop thinking of storage as a utility. It's not just a place to put things. It's a series of strategic decisions.
It's about mashing the tool to the job.
Right. If you put archival data on high-speed block storage, you're just burning money. If you put a high-performance database on S3, your app will probably crash. You have to understand the behavior of the storage to build a resilient system.
And sometimes the most resilient system involves a gray box in the back of a UPS truck.
That's still my favorite part of all of this. The cloud is virtual, but the data is physical. And sometimes physics wins.
I think that's a perfect place to leave it. Next time you upload a file, maybe spiff a thought for where it's actually parking. Thanks for diving in with us.
See you next time.